Hey, welcome back to section 6 of this packet. This is geometric series, and this is a whole lot more difficult, but I don't know if you've ever seen this before. I'm sure you have. I think I remember this being something in the 8th grade. But if I want to know what is 0.18 repeating as a fraction? I know it's a fraction because it is a repeating decimal, and every repeating decimal, terminating or repeating decimal, can be written as a ratio, a rational number, as a fraction. So how do I figure this out? Well, first of all, I let n equal this, and then recognize that because there are two digits repeating, I'm going to multiply both sides of this equation by 100, and then subtract one from the other. So if I multiply this side by 100, I get 100n. If I multiply this side by 100, what I recognize is this 0.18 repeating is 18, 18, 18, so forth and so on. If I multiply this by 100, let's move the decimal over 2 places, but I still end up with an infinite number of 1/8. There's a whole bunch, and then when I subtract them, what I see is all of the 1/8 cancel out. I'm just left with 18. And 100n minus n is 99n. There's no repeating decimals. I just divide by 99 and get 18 over 99, which I believe 9 goes into both those. 9 goes into 18 twice. 9 goes into 9, 9, 11. So apparently 2/11ths is 0.18 repeating, which we can prove very nicely right here with the calculator. We can see right there that 2/11ths is 0.18 repeating. So that's kind of a cool thing, right? Well, that's the process of thinking that I do with the summation stuff. And boy, I tell you what, I don't know how much more I'm going to share about this right here, other than just to kind of work through a little bit. If you don't follow this, that's gonna be just okay. But you know that the first term is a1. What's your second term? a1 times r. What's your third term? a1 times r squared. What's your fourth term? a1 times r the third. And all the way up until you get to your last term, which is a1 times r to the n minus 1. Remember, it's always one less because you started off with a step already. Well, let's say I multiply both sides of this by r. So s, the sum times r, equals, now all of these get an additional r multiplied on them. The a1 gets multiplied by r and becomes a1 times r. I'm going to line it up underneath the other one. And I shift all these down and find out that every single one of these terms is matched with every single one of these except for the first and the second. Those all cancel out, and I'm left with Sn, the sum minus the sum times r, equals a1 minus a1 times r to the n. Factor out the sum, leaving a 1 minus r. Factor out the a1, left with a 1 minus r to the n. Divide by 1 minus r, and I have this formula right there. So the sum of n terms of a geometric sequence is my first one times 1 minus r to the n over 1 minus r. And that's a pretty neat idea. It works great. What's nice about it is there's no minus 1 for the n. So if I say a sub 1 equals 3, my common ratio is 2. What is the sum of the first 8 terms? In other words, what is 3 plus doubled is 6, plus doubled is 12, doubled is 24, doubled is 48, doubled is 96, doubled 1, 2, 3, 4, 5, 6, doubled is 192, doubled is 384. If I want to know the sum of those numbers, I can't do the first plus the last and expect that to work. It doesn't work the same way because it's not arithmetic. But I could write them all out and just add them by hand, or I could recognize that it's my first term of 3 times 1 minus 2 to the 8th over 1 minus 2. That's 3 times 2 to the 8 is 256, 512. 512. 1 minus 2. This is 3 times, no, it is 256. It is 256. This is negative 255 over negative 1. That's going to be 3 times 255. That should be 765. So I'm guessing that when you add all those together, you also get 765 as well. Pretty slick, right? Now that's a lot of math, especially when you don't have the calculators. I'll show you how to use Desmos in a much more efficient way to go in just a moment. But that's the geometric series. Whew. Let me know if you have any thoughts or questions.